Hello folks, welcome to Lantamer Stream. Hope you're having a good weekend. I've been doing some grinding today. Had to do a little work. I was going to stream early, got interrupted, but I've been looking at some ARP. The ARP family, I should say. We're going to talk about ARP requests, ARP replies, gratuitous ARP, inverse ARP, RARP, all the good stuff. It's kind of fun to say, right? Anyway, our wallpaper of the day here for this lab I'm going to do is, of course, from the ULA launch, the solar probe, Parker solar probe launch. That was, Sunday, I want to say, or Monday, early Monday. I think it was early Sunday. Anyway, cool shot from their Flickr site, courtesy of the NASA HQ Flickr site. So let's talk some ARP, folks. Actually, what I want to go over first, and we're pulling up the chat here, the agenda for today, which I always post beforehand on the Google Drive share. For now, I'm looking at moving to either GitHub gist, or I may just do a GitHub page. I'm not sure for all the agenda documents. But anyway, this is what we've got going on today. And today we're wearing, just so happens, wearing, as Dr. Disrespect would say, black on slate black. Just so happened to be that today. So anyway, I want to talk one thing. I was reading a blog earlier today by Tim McConaughey talking about how, he was interacting with his community. He happened to be on Router Gods, and they would lab together, but it made it kind of difficult after he had failed the lab exam, because obviously he wasn't able to lab, in front of other people. Hey, Bashy Mash is in the house. Great to have you. I hope you're having a good weekend, having good success today, grinding. But yeah, I just want to talk about that too. Like today, I want to say, I'll say it this time, I'm studying ARP, or have been studying ARP today and all its variants. But that doesn't necessarily mean that just because I have failed the written exam, that I'm studying this because, the material I'm studying is going to be on the written exam, or was on the written exam. No, I'm not going to necessarily, you're not going to know if I'm covering something because I saw it on the exam or not. All you can be assured of is that it's on the blueprint, right? In this particular case, for example, I was looking at Loop, the Loop protocol, which, caused a little, some interest on Twitter and Instagram, and that actually led me to, someone asked about ARP, or they said, this could be a gratuitous ARP because of X. So yeah, I was like, you know what, I want to say, no, that's not correct. I want to respond, no, the Loop frame you're seeing is not that type of ARP. But then I discovered, well, really, I can't answer definitively because I need to dig a little more and get a little better solid foundation to be able to answer with authority. I'm not going to answer. I did look it up and find that, but I could not disprove because I didn't have enough knowledge about ARP and the difference. So anyway, I just say all that to say, I'm going to be covering a lot of topics. I'm going to be covering cloud. I'm going to be covering blueprint topics. But I don't want you to think that just because I'm covering them that this is material I saw on the exam. As a matter of fact, you'll see in my current attack plan, this is step 1, and step 2 is fail notes review, which I'll never reveal on stream. All my notes from the fail. And then networklessons.com, layer 2. I'm bouncing around a little bit there. So you don't know if I cover something on here and I'm, talking to something, or hey, we got a host from the Blind Hacker. Thank you very much, Blind Hacker, for that host. I appreciate that raid. Thank you so much. And Bashy Bashy, yep, last 12-hour shift for the week. Let's get her done. Yeah, man. 12 hours. So are you on the early end or the tail end of that, Bashy? Curious. Because I'll be studying some tomorrow too. Or maybe you're talking about work. But anyway, yeah, appreciate the host. So yeah, we're talking about these different ARP. I'll move on from that. Like I said, you don't know if I'm covering any of this stuff is related to written or not. I'm trying to become an expert, right? And so I just want you to know that. 7 p.m. to 7 a.m. Oh, wow. Okay. So just starting work. Gotcha. Last one. Woohoo! Yeah, you'll pull through it, man. 12 hours to go if you're in Eastern time. So let's talk about the ARP family. And what I found is when I was looking at this, not only did I not know, I think it was a question related to gratuitous ARP. Someone was saying this loop frame, this must actually be gratuitous ARP. Hey, this is Blind Hacker. No problem, man. I stream similar to you, but I cover cybersecurity. Stick together. Yeah, man. Hey, Blind Hacker, what I'm going to do is I've actually got a Nightbot command here, more streams. And this is just networking streamers. So what I'm going to do is I want to add you to this as well, my friend. Because there are people like in this Discord for this channel that are interested in security as well. So I'm going to, I'm assuming it is twitch.tv, the Blind Hacker. Let me know if that's not it. These are in alphabetical order here. Yeah, man, definitely. And appreciate the raid. Also, I'm going to add you to auto host as well because, like, usually I'm auto hosting Bob Ross because none of these streamers, you know, we're few and far between for right now. So, and don't worry about links. I could do this all day. Oh, yeah. Okay, there it is. Cool. Yeah, thanks for sharing your. Like I said, I'm all about community. I love when people come in and share their streams as long as they're related to networking. You know, we got to stick together, like you said. So, yeah, I'm going to add you to my auto host as well. So, yeah, folks, ARP, this is related to security, too. There's a lot of hacks related to ARP, low-level type hacks. But one thing I found I needed to bolster my knowledge on was the inverse, the difference. You know, can you say you know the difference between inverse ARP and reverse ARP? They have the same purpose, you know, essentially the same end goal, but there is a difference there, right? So I'm going to go over those, and we're going to do a little bit of labbing here. Nothing deep or profound, but I'm just going to go over these different types. So we'll start with the ARP family, the packet types. You have your basic ARP request, right? So let's take a look over here at, I've got a little lab running. This is EvenG Pro. I've got host 1, host 2, and router 1. So this guy is, these are all, and the switch, this is all on VLAN 1. So they're all in the same broadcast domain. And this is 10.11101, this is 10.11102, this is 10.11101. I think I did a drawing. But either way, I've got Wireshark running, and we're looking at ARP packets. There's some gratuitous ARP, which I'm going to cover in a minute. But first, we'll just go ahead and put a few, show you some examples of your ARP request and your ARP reply. This is your basic, right? So if I look at my host here, which is a router, but he's acting as a host, right? So he's just got this IP address, and that's it. There's no routing running on here. We're talking about a single broadcast domain, single VLAN. If I do show IP ARP, now notice here what's interesting is we could talk about sort of order of operations. You already see gratuitous ARP here. And just be assured that basically when I boot up this router, any interfaces that have IP addresses that are on an Ethernet link, it is going to send a gratuitous ARP just announcing himself to the world, right? So that's the only ARP entry I have, which is my own. However, over here on host 2, yeah, all he has is his own. And I want to communicate 10.1.101.1 knows that there's a .102, right? Right now, based on his ARP table, he has no idea how to get there. He's on a shared Ethernet link, right? Not a point-to-point. So I'm going to do a ping. And we should drop our first or second ping, which we do. We drop our first, and then we get the 4. And the reason there's a drop is because when we send the initial ping, we don't know the MAC address of, we don't basically know in our forwarding table, we don't know how to send the packet with the correct destination MAC address. So first we send an ARP request. And you'll see it here, right? Now notice that notice the source and destination here. We're going to delve into this a little bit. The destination, of course, is always first because that's what the forwarding device is most interested in. First is the forwarding address. And we see it is all F's in hexadecimal, but it is a broadcast, right? So send it to every host on the link. And this is my source. The Ethernet or the Ether type is 0x0806, which is ARP request. And we notice that's how this is broken down here in Wireshark address resolution protocol request. We've got the hardware type, protocol type, hardware size, protocol size, and request. Now, the only difference between a request and a reply packet is this opcode. You can sort of derive what kind it is based on what is here, the sender MAC, sender IP, target MAC, and target IP. But this is what determines it, and that is in the Ether type opcode, which is right there. So here we have it. Look, I'm the sender. This is my MAC address. This is my IP. This is the IP I want to talk to. Obviously, I don't know the target MAC address, so I'm sending all zeros. And that's how the ARP request is formed, right? Pretty basic stuff. I know the IP I want to talk to. I don't know the MAC address. ARP is what gets that, populates my table for me. Now the ARP reply, of course, came from router or host 2. And again, the only difference here is the opcode is 2, which is a ARP reply. We see that this time the destination is a specific MAC address, right? We know, the request had the source MAC address so that someone who's going to reply knows who to send it to. And so it doesn't go to all the other hosts, right, on the network. So it goes to this device, and he says, look, this is my MAC address. You want to know who had this IP? 10.1.102. This is it. So now if I look in the ARP table of host 1, notice now I have both, and I have the hardware address. Pretty basic stuff, right? And by, association, or, basically host 2 is able to derive, not only does he send his information, but now he's been able to determine, what is host 1's information. Because host 1, by sending his request, essentially declared his own information. So now our ARP tables are populated, and that's a lot of the good stuff that we know and love, right? That's pretty simple. ARP request, ARP reply, not much complication there. All right, now gratuitous ARP. Gratuitous, the name kind of implies what it is. It's gratuitous. Nobody asked you, your business, but, they're telling you anyway, is basically what that is. There's a lot of uses for this, though. Just think of all the scenarios besides just doing a ping where there are technologies in the network that change what the ARP table, let me say this, there are protocols or technologies that will change the state of the network and require that neighbors update their ARP tables, right? Or interested hosts on the network would need to update their ARP tables. But they don't know through the natural process of ARP request and ARP reply, right? I'll give you an example. Let's say HSRP. We can also think of in VMware, right? So there are a number of situations where there might be a change on the network. Load balancers might be another example where there's been a change made by a host, to which interface an IP is being used on, where it needs to now, that host knows about the change, but it needs a way to inform the other hosts on the network or on that segment, even though they didn't ask, right? So there are a lot of scenarios like that. Here's another scenario. Let's say so let's go real simple. Let's make it real simple. I am host 1, right? If I do show IP ARP here, host 2 has an ARP entry for this IP address. But I come over here to host 1 and I change my IP address. All right, so what's going to happen? First of all, this ARP table is going to be, without any other mechanism, this ARP table is going to be stale. This is invalid, right? This MAC address is no longer associated with this IP address. It's associated now with .103. But guess what? We have gratuitous ARP, and here it is. So there was a change on the network. Host 1 knew about it. And, obviously the software recognizes that we need to update everyone else's ARP table. So he sends a gratuitous ARP. Now this is a reply, and I'm going to go over that in a second. But yeah, we have here the ether type is still ARP 806. The opcode is a reply. And the reason Wireshark knows, actually, how does it know? 806, Ethernet type 1 is gratuitous. Okay, so there's but that is derived, I believe. Yeah, and the reason it's derived, just think about this, right? So this is opcode. It's a normal reply, but think about it. Who am I replying to? I'm replying to everyone. Generally, an ARP reply is to a specific MAC address, right? Not to an all hosts address of FFFFFF. So it's basically a normal ARP reply packet. There's not per se gratuitous ARP packet. But just by nature of the fact that, it is a reply and it's going to everyone, we can derive from the fact that that is a gratuitous ARP reply, right? Which makes sense in a way. Even though it's a reply, this is when someone would be basically informing the network of what my address is in a reply. So anyway, we belabored that point. He sends 2 of them. I'm not sure why 2 of them are sent. Maybe it made one when I made the change, and then when I exited, I don't know. I don't know why it sends 2. 2 for emphasis. Is gratuitous true? Is gratuitous true? Yeah, I don't know. So it sent 2. And that is how, now if we look over at this other host 2, show IP ARP. Oh, interesting. This has not updated his table. Oh, the reason is because the switch now knows. Remember, we have a switch in between. So, yeah, let's look at the switches table. I think I already have it open here. Show ARP. In this case, it'll be his MAC address table. Okay, so yeah. Well, that's interesting. All right, so let's do ping. So we already see a limitation of the gratuitous ARP, right? The gratuitous ARP, really, this segment extends to here. And the switch did not forward the frame to all hosts. Show IV ARP. Yeah, so he did not get the update. But obviously we're not relying on the ARP table. Remember, the ARP table is just to map max to IPs. So host 2 still needs to know about 103, right? So what he's going to have to do is when he tries to ping so even if these guys would have been on the same physical link, H2 would have received the gratuitous ARP, but it doesn't mean he still knows that he needs to talk to 10.1.103 now, right? We'd have to rely on DNS or some other, feature to learn that if we want to communicate with host 1, we need to now talk to 1.103. However, because he is not directly connected, host 2 to host 1, when I try to talk to 1.103, I'm still going to have to do an ARP because I don't know it, right? So what we're going to see is an ARP request. Where's my Wireshark? Yeah. So here's the request, which is broadcast, and then host 1 sends a reply, right? Hey, 1.103 is over here. So if switch 1, for example, was running layer 3, like a SVI, and he was trying to ping 1.103, he would not have had to do an ARP request, because on this segment we receive the gratuitous ARP. So I hope that makes sense. All right, so that's what a gratuitous ARP is. And again, like I mentioned, that is just, if you change an IP, you change an interface. There are other technologies, though, that use gratuitous ARP, especially when you're talking about like a virtual IP, like in a load balancer or an HSRP, where gratuitous ARP is used to update hosts that there's been a change. Now, inverse ARP. Inverse ARP is the opposite. So I don't know the IP. I need the IP address. I know your DLCI, and that's where we're going to find the differences between inverse ARP and reverse ARP. These are basically, in the case of an inverse ARP is, I know a DLCI. This is frame relay, if you're not familiar. So you're not going to see this that much, right? Because frame relay, I don't even think it's part of the blueprint anymore. It might be. I need to double check. But yeah, because I did see some frame relay in the walk-in lab. Sort of a portion of what the real lab would look like. But I think it was an older lab. So yeah, I don't think we have any frame relay at all. But yeah, I know your DLCI number, and I need to know your IP address. And I did go ahead and pull up so that we're seeing it in Wireshark. Someone had posted one of these. And let's find our inverse ARP in Wireshark. So here it is. Here's an inverse ARP. Again, this is a frame using layer 2 is frame relay. So we got DLCI 201. It's like, hey, my IP is this. We're on a DLCI, so we're on a virtual circuit. Please tell me, you on the other end, tell me what is your IP. So the target IP address is 000. And we get an inverse RARP protocol back, which is an inverse reply that says, hey, 990001 on DLCI 102. This is my IP address, right? That's how that works. So yeah, not an Ethernet standard. That's frame relay. And then reverse ARP, as we know, as I mentioned on this channel before, reverse ARP is an old mechanism that has been since replaced by BootP and DHCP. So here's my MAC address. I don't know the IP address. In fact, I don't know my own IP address. What is my IP address supposed to be? That is reverse ARP. So it is a reverse, because in ARP, I know the IP, I know my MAC address. I need to know what MAC address goes with that IP. In this case, I know my MAC. I'm going to send a broadcast. I need to know, someone needs to tell me whether that's a RARP server, right? Or another host that's listening, and we'll go into that in a minute. But it's going to say, hey, dude, with that MAC address, your IP is this, right? So it's not really used much anymore at all for, obtaining an IP address, in the sense that, bootstrapping a host on the network. That's what it used to be used for. Nowadays, though, and I have some links here below, VMWare is using this. So, and there are probably other uses of this for reverse ARP. I don't know if any of you are familiar with VMware, if you've worked with VMware that much. I used to be a VCP, VMware Certified Professional, a while back. So I'm familiar with this, NIC teaming, but this is where you have a notify switches, and essentially this is kind of like load balancing, not really NIC teaming, but it's more like sort of a failover mechanism. But anyway, this is where, you have essentially an IP that's being shared, and reverse ARP is kind of used to communicate changes in the network. As a matter of fact, I believe that this is what is also used when they do, not only for NIC teaming, but for vMotion. So again, the concept of vMotion, I believe that's what this link is here. Yeah, vMotion. And I'm going to share these links with you folks, in case you're interested in that. But yeah, vMotion essentially, right? You've got two hosts, and you've got a virtual machine with a static IP address that moves from one host to another. So VMware just happens to use this old protocol, reverse ARP, which does the job perfectly, to sort of communicate, hey, there's been a change on the network, and we're going to remap which MAC address has this IP, right? So, and again, really the purpose of ARP and the family of ARP and these protocols is to successfully map a hardware address to an IP address, right? Then you have proxy ARP. Proxy ARP would be in this scenario, let's say this was a firewall, and the firewall had an interface. It had these two hosts that are on the same subnet, and it had two different interfaces. So obviously, if he sends an ARP request, which is a broadcast, a firewall is not going to forward a broadcast, right? It just doesn't. That's not how it works. So what it will do is it will, on behalf of this host, so we can discover this one, it will send an ARP request down this segment with its own MAC address as the source. When the request comes back, it will formulate a request packet. And so it's a proxy, right? That's the definition of a proxy. By the way, we have, I meant to show you this, reverse ARP request. And I believe this is from that VMware article. So yeah, this is a broadcast and a source. But again, the difference here is we don't have the IP. By the way, if you look at the ether type, it's also 0806. Same ether type. You know, it's funny because when we looked at PPPoE, it had a couple of different ether types during the, you know, for the discovery and also for the session phase. It had an ether type for each. ARP, this is all 0806. But again, I think it's by implication here you have a 3, which is a opcode 3, which is a reverse ARP request. You can also kind of derive that from what we see here. So we have the sender, and the target is also himself, and the sender is zeros and the target is zeros. So in other words, notice it says who is. So it's kind of having an identity crisis, right? A reverse ARP. This is my Mac. I don't have an IP. I need to know, by the way, who is the IP for this Mac, which happens to be me also. So it's an interesting sort of, you know, but it works. It's simple. It's an old protocol, but it works. It does a trick. And then we have a reply. Reverse request, which is an opcode 3 also. Broadcast, is that right? No, this is a request, this is a reply. Yeah, opcode 4, sorry. I knew that, I looked at it and said, that can't be right. Here we have everything populated. So this would be very useful in the case of vMotion or some of these other features in VMware where, you know, where a physical address is not really physical anymore, right? So we need to use these Ethernet features, protocol features, to have everything work the way we need it to, right? Okay, what else we got? Who am I? Hey, Tahigo. Hey, with the fam, keep it up. TTYL, take care, Tahigo. Appreciate it, man. In and out. Haven't seen you in a while, man. Hope you're doing well. But yeah, so that those are the ARP types, right? So, you know, I think it's important to know what you're looking at. I think it's important to know the opcode. I think it's important to know the uses of each ARP and the scenarios of where you might need to use one. So it's really good stuff. Now let's talk about securing ARP. Now that we know about the ARP tables, we reviewed that and how these ARP packet types are used to populate those tables or update those tables. Obviously in security, there's an issue where, you know, the packet that we looked at is very simple. You know, basically this is a table entry. This is like, you know, a couple of rows. This is a couple of columns and rows. This is a database record. And there's obviously no real security on an ARP packet itself. But obviously Cisco has mechanisms to secure ARP. It's real easy to spoof an ARP address, you know, and introduce a man-in-the-middle attack. So let's say, for example, I put a host here on the same network, and I can, you know, quickly discover if I send a broadcast, right, ping every host on the network, I can quickly populate my own ARP table, and then I can figure out, okay, well, if this guy, let's see, you know, if this guy is 1.102 and that's his MAC address, I'm going to send a different ARP and I'm going to say I'm 1.102, or even more, let's say our default gateway is 10.1.1, 10.1.1.1. You can say, look, I'm 10.1.1.1, and I'm going to send a gratuitous ARP constantly. You're only supposed to send a gratuitous ARP when there's a change on the network. That's what the RFC says. But obviously anyone can break that rule, and I can come here in this topology and constantly send gratuitous ARPs, so that every time H1 is trying to talk to the gateway and maybe out to the internet, maybe he's going to try to talk to, you know, whoever, Google, instead, those could go to this host here using the man-in-the-middle attack, and then he will send it out to the internet through the gateway. So it'd be very easy to spoof and present a man-in-the-middle attack here and take advantage. As a matter of fact, if you on networklessons.com, he demonstrates this. It's pretty cool. I watched it. There's a video, and he has a lab, and he has some, you know, configurations that you can use and actually duplicate this yourself. But it wouldn't take much of a Google search to be able to replicate this, right? So what Cisco has is to secure this is DAI, Dynamic ARP Inspection, is a security mechanism. And many of you know what that is. You know, you work with essentially dynamic ARP inspection works with the concept of a trusted and an untrusted port. So if you can define a trusted port, like a port leading to a DHCP server, and you could say, okay, I'm going to trust everything that this DHCP server says. That's going to be the source of truth about, you know, what MAC addresses are legitimate on this network. What Ethernet addresses and IP addresses. You know, basically, I'm going to get my table from the DHCP server. So if someone else comes along and says, you know, I'm this IP and this is my MAC, if it doesn't match what I've learned from the trusted port, the DHCP, I'm going to discard it, right? And there is a process with DAI to configure how to act. You know, obviously, an untrusted port, when it first comes on the network, it doesn't have an IP address yet. So there is a process for the router to allow the port to obtain, send a DHCP request, obtain an IP, and then from that point forward, that table entry will be trusted because, you know, it came from the DHCP server. But that is a very good way to secure ARP. Obviously, there are other mechanisms. You know, if you are able to protect your network via network emission control, even better, right? So even before it gets on the network, a host gets on the network on an untrusted port and requests a DHCP address, you've got a mechanism to sort of authenticate the device. Also, there's an ARP storm. I found a packet PCAP like this, and this is just a device. There are other mechanisms for this as well. Storm control, things like that on a switch. And let's see here. Is this the one? No. ARP storm. And if you look at the time on this, this device is sending these ARP requests and just, you know, slamming the switch with junk. And what can happen is if the switch, you can actually overwhelm the switch's cam table. And then traffic just starts to get lost. So this is kind of a sort of like a denial of service attack, right? And storm control and things like that, there's features that you can use on the switch to mitigate a port that's trying to send that many ARP requests, right? So yeah, kind of a cool review. This is good for me to review ARP. Now, I think if that question that came up again about loop, the loop protocol, and ARP or any ARP question in general, would be much better equipped to handle that. So fun stuff. My current attack plan, folks, is to continue working on this failed notes review and network lessons. I'm going through that. I'm also looking at some redistribution. OSPF to OSPF, EIGRP to EIGRP. I'll probably work on that tonight or tomorrow. And then updates to stream, not really much going on. I am back. I was out this week mainly for work. I had to stream twice from a hotel room, but, you get spoiled, man. I tell you. Working from home, working remote, you get spoiled pretty easily. So, but I'm glad to be back. I got all my screens now. I got my good mic, my do-rags. I got my lighting. And so we're going to keep the stream going and, study every day, right? And hope your study plans are going well, whether you're doing security, whether you're doing networking, routing and switching, service provider, data center. Keep on at it, follow me on Instagram. I have been trying to up my Instagram game. There's someone I wanted to highlight, has a really cool Instagram account. Darn it, I didn't put it on here. I promised him I would do that. Let me find his Instagram account. It's a network, it's about networking. And he actually tagged me in a photo, which is pretty cool. It's a good tactic. I like it. If any of you are really into, like, I watch a lot of Gary Vaynerchuk, and I watch a lot of, Casey Neistat. I try to keep up with the superstar streamers, trying to learn from them. And so, yeah, this is him here. Tomas Schwartz. He's got a really cool Instagram site. So I'm trying to up my game. I'm going to ask him for some tips. But he's got quite a few followers here. But yeah, check him out. I'm trying to hit all the social media. A lot of people say for networking, all I need is Reddit or Slack. Guys, I'm on them all. I'm trying to leverage Instagram to, generate awareness for the channel. Instagram, Discord is my mainstays, and Twitter. But definitely check out this Instagram account. He's also on a CCIE journey, routing and switching, I believe. So good stuff, and he's got some great motivational stuff out there. But yeah, there's a lot of links here, guys. Let me first get into the trivia. How can you tell the difference between an ARP request and an ARP reply? We kind of went over that by showing you the opcode. Also, what is the destination address, right? Generally, if it's an ARP request, it's probably going to be going to a broadcast, right? Not always, but generally it is. Now, one thing I promise, how can you tell, what is the difference between a gratuitous ARP reply and a gratuitous ARP request? We talked about gratuitous ARP, and this one bothered me. I'm like, it should be a reply, right? That's kind of the mechanism. It's opcode 2. That's how you would know, really, that I'm letting everyone know I'm reply, even though you didn't ask. A reply is basically how you're populating someone else's ARP table. That's how you're updating their ARP table. So what in the heck is a gratuitous request? Well, I had to go to the RFC, which is here, and they cover it very well. Essentially, gratuitous ARP reply is the way to go, is a recommended way to go, but they did address it here because they said that there was deliberation from 2000 to 2008. Shouldn't ARP announcements be performed using gratuitous ARP reply packets? So it makes sense. On the face of it, this seemed reasonable. Someone did a good job explaining this. A conventional ARP reply, let me blow this up because I know it's hard to read. That's not what I wanted to do. Brave is a little different. Okay. Control equal. Why would you do that to me? But yeah, do a good job here. It said the term gratuitous reply would seem to apply perfectly to an ARP announcement. an answer to an implied question that, in fact, no one asked. However reasonable this may seem in principle and practice, there are two reasons to swing an argument in favor of using ARP request packets. One is historical precedent, and the other is pragmatism. So a number of operating systems, vendors, started sending gratuitous ARP information using a ARP request packet. So in order to be backwards compatible, yes, you should actually support a gratuitous ARP request. As I say here, BSD Unix, Windows, Mac OS 9, Mac OS 10, all use ARP request packets as described in Stevens. At this stage, trying to mandate that they all switch to using ARP reply packets would be futile. So it's actually written by an engineer, doesn't it? As a matter of fact, this is written by someone at Apple. So I can understand why. They don't want to rewrite all their code, right? To comply with the previously published standard. The practical reason is that ARP request packets are more likely to work correctly with more existing ARP implementations. Some of which may not implement RCA26 entirely. So it's a pragmatic approach. Yes, we could be extremely strict, and it would make more sense to use an ARP reply, but let's face it. A lot of people start out using the gratuitous ARP request, and let's be practical here, right? So anyway, they basically do the same thing. They're going to come from the same host, trying to accomplish the same purpose, and they're going to populate the neighbor's ARP table anyway, whether it's a request or reply, right? Some other things, VMware use of reverse ARP, I posted those. Yeah, we updated our list of streamers. I've added 2 streamers today, guys and gals. Actually, you can always do in Discord server or here on Twitch. There's a Nightbot command. You can say more streams. And we've added 2 people on here. One of them is, I think it's iWizKid, which is here. EFZips, I can't say it. EFZepit, yeah. Anyway, and then Blind Hacker, we just added that on here, so which is awesome. It's great. So yeah, check them out, folks. If you're not following them, there's also somebody on YouTube. Definitely check them out. Support the community. Most of these are people working on certification or trying to learn networking, trying to meet up with other people. So definitely check them out and give them some support. That's all I got, folks. We shall see you back here tomorrow, hopefully, on Lantamer Stream. Generally, on Sundays, we try to stream at 12 noon Eastern. So tomorrow, we'll probably be working on some of these other network lessons. I don't know exactly what that is right now, but I'll let you know in Discord. And thanks so much for the support. Appreciate everyone stopping by. Definitely give us a follow here on Twitch if you're not already. If you have an Amazon Prime subscription that you have not used, I'm an affiliate here. You can definitely hit that sub button and give us some support there. And also you follow me on Instagram, Twitter, YouTube, GitHub. All the links are below. Thanks so much for stopping by. Wishing you all the good bits in your studies and in your labs. And you folks have a great rest of your weekend. We'll see you tomorrow back here on the Lantamer Stream. Thanks again.